Hello ladies and gentlemen. Today let's look at double angles. Last time we were doing compound angles. This time I want us to look at double angles. Let's look at double angles. So we were doing compound angles, meaning angles of this form, A plus B. In our sign we had an A plus a B. That means two different angles which we agreed that would be a sine A times a cos B plus a cos A. Since we have a sine A, we need a cos A here. A cos A times a sine B. Because we have a cos B, we need a sine B this side. So that's what we agreed on, meaning we have a angle A which is different to angle B. It gives us this expansion. Now we want to see what happens when you have two angles but that are not different, meaning maybe you have a sine of A plus sine of A. Yeah? So we basically follow the same procedure in which we say it's a sine of A times a cos of A plus a cos of A because we have sine A here times a sine of A because we have cos A here. So we have accounted for our angle A, our first A, and for our second A here. But now what you realize that here is that an A plus A is equal to 2A, meaning we're going to have a sine 2A is equal to, we have a sine A times cos A and a cos A times sine A, which is basically the same thing, meaning we can say this is sine A times cos A plus sine A times cos A, which gives us 2 sine A times cos A. Now what we see here is that when we have a 2 here, it means that can be written also in this form, né? Meaning this is a double angle because we have a 2, that A is double. And then to write that down, we write it in this form for sine ratios. So this is your identity, your double angle identity for sine ratios, né? So now let's make some example in how we use this in our problems. So if we have sine 6x, if you have sine 6x can also be written as sine 2 times 3x. Because we know that this form, if we have a 2 here, it can be written as an identity, meaning we can write it as in this form. In this form, meaning we're going to have a 2 outside. Here's our 2 outside. And then we have our sine. Now what is our angle going to be? Remember here we said 2A, our angle will be A. Here we have taken the 2 outside, meaning our angle will be 3x. 3x times cos 3x. What you will realize is that the number that will be inside this ratio, the angle, is always half of this angle that is here. So here we have a 6x, and then in this product of sine A and cos of sine 3x and cos 3x, we gonna have a half of this 6x, which is a 3x. Here we have a 2 here, and then we have a half of that 2, which is a 1. Meaning, if we have a sine 4x, we're going to have a 2 times 2x, because 2x is a half of 4x, times cos 2x. So now if you find it hard to comprehend all of this, you can always start by writing it with a 2 aside, meaning you're gonna say sine 2, and then what is a factor that will give us a 4x is the 2x. And then from here you know that it will give you a 2 sine 2x times cos 2x, and then that will be your answer. So these are examples of double angle identities for our sine.